Hey guys, welcome to the final video in our indices and surds topic. Now in this video, I just want to give a little bit more love to surds and just give you guys an extra video so we can practice working through some slightly trickier surds questions, the kind of harder ones you'll get so far in year 9. And what we're going to do is we're going to run through them a little bit slower just to really get you an idea for how you'd approach these questions, and as well so you're not rushing ahead and making little silly mistakes, because that's typically what can happen, especially when we deal with surds. Now, I have the first question here, which we are dealing with addition and subtraction of surds. So remember, when we do these types of questions, we want to find the like surds in the same way that we would find like terms in algebra. So this 2 root 3 here, we want to find a like surd to that. And to do that, we are looking for the actual surd, a surd that looks alike to this one. Now, that one here would be this particular guy here. Now, here we're minusing root 3. Now that's the same as thinking of minusing one lot of root 3. So I've just put that here just to avoid confusion. Now another pair of like surds are these guys here. So I have 5 root 2. Now the surd here is root 2. So I can see another root 2 over here. And that is going to be my like surd to that. So first of all, I'm just going to group these together just so it becomes easier and a bit less confusing for me when I do the actual operation. So I'm going to write the like surds together. Okay, now all I have to do is treat this like I would algebra. So 2 lots of root 3 minus 1 lot of root 3. That just gives us 1 lot of root 3. Or I can just write this as root 3. And then 5 lots of root 2 plus 4 lots of root 2 gives me 9 lots of root 2. And because this and this are not like surds, we've simplified as far as we possibly can. We have to leave it here. So that's how you can work through a slightly trickier and maybe busier addition and subtraction question with regards to surds. Now in this next question, we are required to multiply these 2 surds together. Now I'm going to just take a second to rewrite this, because we remember when I write, for example, 3 root 2, what's implied here is 3 multiplied by root 2. In the same way here we have 5 multiplied by root 11. So I'm going to say this is the same as going 3 times root 2 times 5 times root 11. Okay, now if you think way back to when you first learnt these operations, your simplest memories of multiplying anything, you may remember that it doesn't matter which order you multiply in. So 3 times 2, for example, is going to be the same as 2 times 3. Both of these give me an answer of 6. So that means that we can rearrange this numerical expression here into something that's easier for us to work with. So what I'm going to do in this next step is I want to group the surds and whole numbers together. So I'm going to write, instead of 3 times root 2 times root 11, I'm going to group my whole numbers together first. Give me 3 times 5. And I'm going to group root 2 and root 11. So that way I can really, it's just a strategy for us to avoid any confusion when we do the multiplication. And it also makes the question a lot more approachable than this thing at the top. because by that I mean the very first line of the question. Because now it just becomes an exercise in multiplication, and I can do these separately, right? So 3 times 5, that gives me 15, and that gets multiplied by root 2 times root 11. Now, if you remember from the previous video, this is the same as the square root of 2 times 11. So I can write the product of these two under one square root instead of 2 separate ones. So what I wind up with is I get 15, and instead of a multiplication, I can just write this next to my surd, because it's just a shorthand way of writing it, same as with algebra, what we learnt. And 2 times 22 gives me, 2 times 11 gives me 22. So my answer here is 15 root 22. And my 22, of course, we can't simplify this any further because 22 is not a perfect square. So root 22 gives me an irrational number as an answer. So this is a surd. And surds we have to leave in this particular form here. So I'm just going to leave my answer as so. And that little bit I talked about, checking if this is a perfect square, is going to become useful, you'll find, in the next question. So I have here 2 root 75 divided by root 3. So what I want to do is I am assuming here that I have lots of root 75, and that's getting divided by one lot of root 3. But this particular thing here, this is like saying 2 times root 75 divided by root 3. Now, because we have a division of surds happening here, I can write these both under the same division, under the same square root. I can do this division just like this. This is from what we learnt in the previous video. So, what I get left with is 2 root, because I can write this without the multiplication sign, just writing 2 root, and I want to do 75 divided by 3, and this gives me 25. Now I want you guys to ask yourselves, as I said in the last video, is this a surd? Now the answer is actually no. Because remember, 25 is a perfect square. So when we square root 25, that's going to give us a whole number of 5. It's going to give us a rational number. Surds only are square roots where we only get irrational numbers as an answer. So for example, 2 and 11 are not perfect squares. They give us irrational numbers. So they are surds. Root 22, also not a perfect square. Well, 22 isn't a perfect square. So when we take the square root of that, we get an irrational number. This is a surd. Root 25, however, when we ask ourselves, is this a surd? The answer is no. So we can always double check whether our final thing under the square root sign is a surd or not, because that tells us if we can simplify further. Now, I have 2 times root 25, but I can rewrite root 25 as 5. So in essence, I'm doing 2 times 5. And that simplifies to 10. So this scary, crazy, weird thing here ends up just simplifying to 10, because once we do the operation here, the division, the answer I get, I have a square root sign, but I don't have a surd. Why? Because 25 is a perfect square. So square rooting that gives me a rational number of 5, which I know multiplies by 2 to give me 10. So these are some trickier questions that I've given you to conclude our topic on surds, and we get left with sometimes these really nice answers. But we don't have to panic when we get questions like this, because as long as we keep in mind the concepts we've learnt, so we can add and subtract like surds, and that we can multiply and divide surds in this particular way, expressing it as one thing under one square root sign, we can perform these operations and simplify these surd expressions. But thank you so much for watching, guys, and I will see you in the next series.